This is question 9 from the SACE Stage 2 Physics course companion from Chapter 2.1 Electric Fields. Here we have two charges placed as shown in that diagram. We have Q1 is 11 microcoulombs, Q2 is -2 microcoulombs, and we have 2 points A and B in between those. So what we need to do first is explain why the net electric field can never be zero at positions A or B. Now it's probably easiest just to redraw this. So we have question A, 11 microcoulombs, and we have -2 microcoulombs. We call this is Q1 and Q2. So here, we'll look at point B because that's probably the easiest first. So here if we have B, now the electric field is the direction that a positive charge would move if placed in that field. So here at B, a positive charge would be attracted towards Q2, so the electric field due to Q2 will be directed towards the right. Similarly, the positive charge will be repelled by the positive charge Q1, so E1 would also be directed towards the right. So in both of these cases, the electric fields are going in the same direction, so they're never going to add to be zero. So that's fairly easy. Over here at point A, that's where things are a little bit more difficult. So here we need to think about charge Q1 and Q2, comparing them to each other to see which one's going to have the greater effect. So here we know from our electric field formula that E is 1 on 4 pi epsilon naught Q on R squared. So here the electric field is proportional to Q. So here, since Q1 has a greater magnitude than Q2, that would suggest that the electric field E1 will be greater than the electric field of E2 if we're just considering the charge. And if we now have a think about the distance, we have the electric field, it's inversely proportional to the distance squared. So the smaller distance is going to correspond to a greater electric field. So here, the distance to charge Q1, R1, is less than the distance to charge Q2. If we were to draw this on our diagram, this would be R1, and the distance to Q2 would be R2. So since R1 is much smaller than R2, that means that the electric field, if we're only considering the distance, would be greater for charge Q1. So here, if we just consider the distances, then the electric field due to charge Q1 will be greater than the electric field due to charge Q2. And since in both of these cases the charge and the distances correspond to a greater magnitude electric field for Q1, then the electric field due to Q1 is always going to be larger than the electric field due to Q2 at point A. So this is a little bit difficult. I think it's easiest just to work through each of the different variables in our formula here to see which is going to have what effect on the electric field at point A. But yeah, once you get the hang of knowing what to do, then these questions become fairly straightforward. But at the moment, it is still a little bit difficult because there are two different things that you need to consider. Alrighty, so now we have to work out, so we have a charge Q3 over here, placed to the right of Q2. We are told that the net electric field at Q3 is 0. What is the value of X? So the question says that the electric field, the magnitude of the electric field due to Q1 has to be equal to the electric field due to Q2 because the net electric field is 0. So we can write an expression for that, and hopefully some things cancel out. So we have 1 on 4 pi epsilon naught Q1 on the distance between Q1 and Q3 is x plus 10 centimeters. So that'll be x plus 0.1 all squared will be equal to 1 on 4 pi epsilon naught Q2 on x squared. So here we have a few things cancel out, that disappears. Now we can just substitute some values in. So we have 11 microcoulombs on x plus 0.1 squared equals, what's Q2, 2 times 10 to the power of minus 6 on x squared. So the 10 to the power of minus 6 is cancel out. So then we finally get 11 on x plus 0.1 squared equals 2 on x squared. So we can use our calculator to find out x, but if you don't want to do that, if you want to do the algebra, then that's fine. The easiest way to do this is probably to start off by cross multiplying both sides. So we'll go 11 x squared will be 2 times x plus 0.1 squared. Now we can expand all of this out. So we have 11 x squared is 2 times x squared plus 0.2 x plus 0.01, which now we can multiply everything by 2. So we have 11 x squared equals 2x squared plus 0.4 x plus 0.02. So now we can subtract 11 x squared from both sides. So we have minus 9 x squared plus 0.4 x plus 0.02 equals 0. And now just have a simple quadratic to work out. You can either use quadratic formula or whatever other method you have for solving quadratics. And you should, if you go through that process, get a value of x of 0.0743 meters. Now, since this is more of a learning question, I'd probably use the equation solver mode on my calculator just to get the correct answer from this point here. But then if I'm feeling like a bit more work, then you can go through and do the algebra just to verify that you got the correct answer. If you do choose to use the equation solver or whatever other method to work out x, because it's a quadratic, there'll be 2 solutions, so make sure that you choose the correct physical value for x. So one of these will be positive, one of these will be negative. In this case, you need to make sure that you choose the positive value of x. And that's it. So the first part was a little bit difficult because conceptually looking at how the charge and distance affects the electric field can be a little bit difficult. Part 2 was also fairly difficult in terms of the algebra, but the actual conceptual understanding of what's actually occurring isn't so bad. It's just going through and doing all the calculations, which makes it a little bit more difficult. Alrighty, and that's it for question 9.